Hi everyone, this is the 11th video of the ACT Math Practice Problem series, and here again we have another nice little problem from the Laws of Exponent. And as I always recommend, before seeing the solution you can pause the video and give it a try yourself, and then after that of course you want to check the solution. Alright, so let's get started. So here we have this expression which is 3 to the power n plus 2 minus 2 times 3 to the power n plus 1 whole divided by 4 times 3 to the power n minus 3 to the power n plus 1, right? And as you can see in our answer options, we really do not have the variable n anymore, right? That means somehow we have to eliminate the n. And how do we eliminate the n? Well, if you look at each of the terms in the numerator as well as in the denominator, you will see that there is 3 to the power n involved with each of the terms in the numerator and the denominator. So now can we write it like this? So let's try to isolate that 3 to the power n from each of the terms. And if we can do that, then the 3 to the power n in the numerator and the 3 to the power n in the denominator, they will cancel out each other and then n will disappear from our expression, right? So let's try that. So now this 3 to the power n plus 2, can we write it like this? We can write it as 3 to the power n times 3 squared, that is actually 3 to the power n plus 2, and then minus 2 times we have 3 to the power n plus 1, so can we write it as 3 to the power n times 3, which is 3 to the power 1, so that is actually 3 to the power n plus 1. And then in the denominator what we have? Well, we have 4 times 3 to the power n, so I am keeping it as is, and then minus we have 3 to the power n plus 1, so can we write it as 3 to the power n times 3 to the power 1, and then from here can we say, okay, then this must be equal to, we can say the 3 squared here in the first term of the numerator, we can say that is 9, so we can say, okay, 9 times 3 to the power n minus, on the second term we have 2 and 3, so that would be 6 times 3 to the power n, and then whole divided by we have 4 times 3 to the power n and minus 3 times 3 to the power n. Now you see we have 3 to the power n with each of the terms in the numerator and the denominator. So let's take that as a common factor. So in the numerator I'm going to write it like this. So this must be 3 to the power n as a common factor. Then within parenthesis we can say, okay, this is 9 minus 6, because from each of the terms we are removing 3 to the power n. So the first term will be left with just a 9, and in the second term will be left with just a negative 6, so that is 9 minus 6. And then similarly in the denominator also we are going to do the same thing. So we will take 3 to the power n as a common factor, and then within parenthesis we are going to write it as 4, because from the first term in the denominator we will be left with just the 4, and then from the second term we will be left with just the negative 3, so that would be 4 minus 3. And now you see this beautiful thing here, the 3 to the power n in the numerator and the 3 to the power n in the denominator, they are going to cancel out each other. So now we are going to be left with 9 minus 6 in the numerator, which is actually 3, divided by 4 minus 3, which is actually 1. So here we can say, okay, then our answer must be 3. And if you look at our answer choices, 3 is under the option number C, so that is our correct option. So we have to select option C. I hope everything made sense. Thank you for watching. See you in the next video.